Again, now consider another type of example in which we see the flow field with no external forces occurring, and we try to apply the momentum flux, rate of change of momentum flux equation, and try to balance the forces that are there. And in this case, the exercise is of a different type, and it is to generate a power generation by using wind. And this becomes very interesting because it has an applications that we use in our daily life, in a house or in an ordinary house as well. So the question is that if there is a wind generator with a 30 feet diameter blade and span has this cut-in wind speed is the minimum speed with which the power can be generated or with which the electricity can be generated. I talk about it in a minute a little more after reading the problem. So this is of 7 miles per hour, at which the velocity of the turbine generates 0.4 kilowatt of electric power. So electricity is generated at this rate when the diameter of the blade is 30 feet and when the wind speed is 7 miles per hour. This is very important. Determine the efficiency of the wind turbine generator and the horizontal force exerted by the wind on the supporting mast of the wind turbine. What is the effect of doubling the wind speed to 14 miles per hour on power generation and the force that will be exerted? Assume that the efficiency remains the same and take the density of air to be this much. Now, this is a very important question. I'm just trying to reflect with respect to Pakistan. At one time, the technology that was available to generate electric power from wind turbines, from windmills, was such that a minimum of 14 meters per second speed was required so that the electricity could be generated. There was an interest, and at that time, and that was in about earlier 1990s, that how we can have, whether we can have sufficient wind speed available so that the windmills could be used or wind turbines could be used to generate electricity in Pakistan. It has many, many advantages. As you know, it's a clean energy. It does not spoil or deteriorate the environment. So no carbon, nothing of the kind is generated while producing electricity, and it's renewable. If the wind is blowing, if we have that wind available, the wind turbine moves and gives rise to, and that energy, wind energy, is converted to electric energy to produce electricity. In our coastal areas, such as in the Makran or Marda, and in areas of Sindh and Balochistan, a lot of survey was done. But I think in those days, we had some problems. The problems are the wind speed is not available throughout the year. The wind is available only for a certain periods of time and not 24 hours round the clock. So that was one problem. And the second problem was that from the data that was collected at that time, the velocity available was not sufficient enough so that the windmills and the power generation from windmills could be economically viable. So that was a bit of a reference, but now I think the technology has improved, and even with lesser levels of wind speeds, the electricity can be generated, and a lot of work is being done, and in fact, a lot of quite substantial energy is being developed by using windmills. We come to this question at hand, and you can see that if this is a windmill, the blade is about 30 meters that they have shown. The control volume of the fluid, and here the fluid is air, is shown to be in the red dotted line as always. the wind is moving from left to right with a velocity v1, the momentum, the whole flux will be m dot v1, which is hitting the wind and gives rise to this. And then from there are, of course, in between the gadgets that convert this wind energy into electrical energy. But we are concerned with the flow field, and that's what we are looking for. The velocity v1 is given to be 7 miles per hour, and it is equivalent to 10.27 feet per second. So you observe that in many engineering applications, still at this time, we keep using the pound foot and so on, those units. And this is different from metric unit system. And m dot, the rate of change of fluid, the mass, will be rho into v1 into a1. That turns out to be 551.7 pounds mass per second. And w, the work energy or the wind energy, is equal to the kinetic energy that is available, and that energy is attributed to v1 square over 2, the term v1 square over 2. When we calculate all this, we obtain energy of 1.225 kilowatt. So that much electricity is obtained. Therefore, the available power to the wind turbine is this much, and the efficiency that we wanted to calculate. And here you note that eta is being used as efficiency of the wind turbine, whereas we also use eta for coefficient of viscosity also. But here in this context, this is being used as the ratio that determines the efficiency of this wind turbine. Taking the other effects also into account, that we obtain that the FR is turned out to be, reaction force turns out to be 31.5 pound-foot. And there is a negative sign attached to this. This only shows that this force is in the inverse direction, is in the opposite direction to the direction in which the fluid, the air is moving. They have also shown it here, and this is to be expected. So the force that is exerted by the wind on the mast is equal to 31.5 pound-foot. And of course, it is in the opposite direction as is expected in this case. Reaction has to be opposite to the action, direction of the action. The power generated is proportional to V cube, since the mass flow rate is proportional to V, and kinetic energy is proportional to V square. Remember, kinetic energy is given by half V square. So therefore, half is a constant, doesn't matter, but V square reflects, we have to take from the kinetic energy, and the flow rate is V. So the power generator is proportional to V cube. From that, we calculate that doubling the wind speed to 14, the original speed was 7, doubling it to 14 will result in the production of the force to be 126 pound-foot. And note that the power generated now is 3.2 kilowatt. So it is much more as compared to what it was before, and earlier very small amount of electricity was generated. So therefore, there is a substantial difference when the wind speed is doubled. The efficiency is increased.